All right, we're good. All right, ODP questions. So how many people have looked at the ODP? Okay.
I don't remember what it was I did on ODP 304, the scanner one.
Mm-hmm.
It had nothing, the problem had nothing to do with the scanner. I don't even remember where was it anymore.
Okay.
It was like weird.
Huh.
Someone's speaking.
Did you get it to work though?
Yeah, I got it to work.
Okay.
I realized what it was and felt really stupid.
That's good.
So
Those are good mistakes to make. So this week we're going to start looking at a different kind of mindset for programming. In C, we tend to write procedural code that starts at the beginning, follows a bunch of steps, maybe loops, does some conditionals, and possibly at some point exits, right? And it's really, we tell the system what to do at each point. And that's one way to write code, but that's very kind of linear, right? What I want to be working on this week is the idea of stateful code. So code that responds to events tends to have a knowledge of state. So this is state as in engineering 250 state machines. Think about a flip-flop, right? So pick your favorite flip-flop, set up the inputs, hit the clock. Sometimes just looking at the inputs you can tell what the output's going to be when the clock ticks, but sometimes you can't. For example, a toggle flip-flop so it's got a toggle input, it's got a clock, and it's got a Q output. And I set my T to a 1, and the clock goes high and low. What is the Q output now? Is it a 1 or a 0? We don't know. What we know is that it's the opposite of whatever it was before the last clock tick, because my toggle input says toggle the output when the clock ticks. And now if I set my T input to a 0 and I tick the clock, the Q output will be the same as it was at the previous clock tick. But we don't know what the output is just from looking at the current conditions. We need to know what state this flip-flop is in. Is it currently in a state where it's outputting a 0 or is it outputting a 1? And if we know that state and we know the inputs, we can say what will happen on the next clock tick. So imagine a function that you call, you pass some arguments, it does something, and it returns a value. So if our function is something like string length, and you pass it a string, if you know what this string is, you can predict what the return value from this is going to be. But it's possible to write a function where the return value depends not just on this string, but on something else, something that's happened in the past. Okay, so that's what I call a stateful system. And ODP 305 is playing with this idea of states. So you're making a class where you have 4 methods. You have a internal variable, which I'm just calling result for this example, and result is initialized to 0. You have 4 methods. The result method just returns the current value of result. Okay. The process method takes an argument, which is an integer, and it either adds it to result or multiplies result by it. Okay. But is it going to add or is it going to multiply? We don't know. We don't tell it in the process method what to do. Okay. We tell it earlier what it's going to do the next time we call process. So we set its state. And we do that by calling either do add or do multiply. Now do add doesn't actually add anything. Do multiply doesn't actually multiply anything. These are just setting the state of the system. So if we call do add, and then we say process 5, it should add 5 to our result. And then if we say process 10, it should add another 10 to our result. And if we say process negative 20, it should subtract 20 from our result. And then if we say do mul, our result doesn't change. But now if we say process 2, it should multiply the result by 2. Does that make sense? There's no reason why we'd want to do this, okay? It doesn't serve anything particularly useful in this case. But it's this idea of keeping a notion of state inside this class. And this is something we're going to be using this week. Okay, I want to start looking at some applications we can use with Swing and putting up some widgets inside a frame. And since Swing is primarily event-driven, you're going to run your code, the person clicks the mouse, and you're going to jump into a piece of code and it's going to say, hey, the person left-clicked the mouse at these X and Y coordinates. And what you want to do at that point is probably going to depend on the state of the system. Okay, so PA3, you're going to build a tic-tac-toe game. And it's going to put up a playing field, and you're going to take turns. The human can make a move, and the computer can make a move, and so on. And what you do in response to a mouse click is going to depend on what state the game is in. If the game is over and the person tries to click in a square to put their mark, you don't want to do anything. If it's the computer's turn and the user clicks in a square to place their mark, you don't want to do anything, or maybe you want to tell them to wait. Right? If it's the user's turn and the player clicks in a square, well, if that square is empty, you want to go ahead and put their mark there. If that square is already occupied, you don't want to accept that as a move, right? So we're going to have this notion of state again, the state system in which the code exists. So this is a warm-up to that. All right, and then tomorrow, ODP 306 will be the same thing, except you got 4 states. And that's a pretty slight tweak, but it forces you to use more than just true false, which is what most people are using for the 2 states so far. So same thing with 4 states, add sub mul div, and a different do op method. It's a single do operation method, and you just give it a command, which is one of these, and that sets the state. And there's sample code there. That opens tomorrow morning, 8:05, so don't do it yet. All right, questions on that? So let's build a calculator. Okay, just as a sample application. And we're going to do a pared down calculator. It's just going to do addition. And we could do this in binary, but let's do it in decimal. So let's start a project. So we'll call it 223 calc. And we'll start with a J-frame. And we'll just call it main. And let's stick with absolute layout, just to keep things simple. So what do we need? Well, we need 10 buttons for putting in numbers, right? So let's go ahead and make a button. We'll call this one 0. Let's make it look like a calculator button. All right, so we want a bunch of these, so I'm going to copy and paste. All right, so there's our buttons. And I can go through and I can click on these and I can change the text on each of them. But let's start getting comfortable with the code. So
What are you doing to skip down those?
I'm doing N for next, and then space, and then R. This is VI. So we can go back, and now we've got, hopefully in the right order. Yeah, we left out. Except it's kind of weird because I put 0 at the bottom usually, but whatever. All right, so we've got buttons, right? So let's think about what happens on a calculator. You've got your keypad. You've got a display. And your display normally shows what?
Numbers and operators?
When you first turn on your calculator.
Oh.
A bunch of it.
Usually it shows a 0 for some reason. A bunch of what?
All the 8s.
Yeah, yeah.
It's first turn.
So throw a 0 on the display. Okay, now you hit a button. Okay, so hit the button 2. What happens? 0 turns into a 2. Okay, now you hit a 2 again, and what happens?
Shifts the
It
first 2 to
displays
the left
two.
and makes an error 2.
Right. And you hit a 3, and you should get a 2, 2, 3. So every time you hit a button, it seems to shift the display over to the left, and then tack your new button's code on the right. Except the first time that you do it, if you just had a 0, it gets rid of that and replaces it by a 2. So let's just mimic that behavior. And you can already see we've got different behaviors when we hit the same button. So we can't just write a set of code under the event handler for a 2 that says do one thing. It's going to depend what the current state is, right? So let's go to our 2 button, and I'll just double click to come down here in the code. And I'm going to write some code in here to add a 2 or replace a 0 by a 2. And then I'm going to have to write the same code for a 3 and a 4 and a 5 and so on, right? And I don't want to do this 10 times. So we got the same thing to do a bunch of times. What do? You throw it in a separate method, right? You modularize. So I'm going to make a single method, and I'm just going to pass this argument to that method. I'm going to figure out from that argument what button was pressed. Okay, so let me just call this click arg0. And I'm going to replicate this code everywhere. And then I need to, so I'm adding my action listener by hand now, right? So what's actually going on in here? We can start to dig into this a little bit. Button is a J button, okay? It has an add action listener method, and what you do there is you put in basically a method. And the method that I want to add as an action listener is actually being defined right here. Right? I'm actually putting the code for the method inside this argument. Everything from here down to here is an argument to this method, add action listener. But inside that argument, I'm actually writing a new method. Right? So I'm making an action listener. I'm constructing an action listener that contains an action performed method. Now I could make an action listener, give it a name, and then put the name of that object as the argument to add action listener. But this is what's called an inner class. And we're actually defining the class inside this argument. Okay, so we're not defining it, we're constructing an action listener and putting one method in it. So don't worry about that too much yet, but if it looks weird, that's why. Alright, so I should have action listeners for all of my buttons now. And each one is just going to call this method click and pass it the argument arg0. So let's just write that method. And let's just print out arg0 and see if we've got anything useful here. So I hit the 1 button and I get a button 1. Sorry, that's my left button. I hit a 2, I get command equals 2. I hit a 7, I get command equals 7. So it's calling my method and it's passing a bunch of information. So if I look at arg0 and I look at the methods available from there, there's a get source method, which will get me access to the J button that was passed to the listener. So let's take the source of the event and assign that to a J button called B. And remember, we have to cast it because getSource returns an object. So now B is the button that caused the event to occur. So let's get the text of that button. We'll put that in T. And then let's just print out that text. So now if I run this, I can get the identity of the button that you've clicked. So without really knowing a whole lot about how any of this stuff works, I just copied and pasted 9 times, right? But what we did effectively was we said, what happens when we hit a 7 button? We're going to call this click method and pass whatever argument that was. Does that make sense so far? You can get there from the design window. You can right click and you can add an event handler and you can add action performed and type that code in by hand, right? But we're editing the source code, and like I say, if we do this carefully, we won't break the window builder setup. If we do something incorrectly, then when we try to switch to the design tab, we may get an error, and you just got to go back and figure out what you did wrong over here. All right, so we have a piece of code down here, click, which is called every time you click a button. And T will be equal to the string corresponding to the button that you pressed. So it'll be a single character. All right, well, let's make a display, and let's start displaying the number that the person has hit. So we'll make a text field up here. Let's make it big, and let's change the font. And I know it's not going to crash on me, because it doesn't do that anymore. And let's put a 0 in there. And let's right justify it. So I just did horizontal alignment right. All right, so instead of printing out the character, well, let's do the following. So let's get what the current text field is, and I'm going to call this thing, instead of text field, I'm going to call it display, because that makes more sense. So we'll get the current text value. And then let's change the text to be whatever's currently in there plus the new character. So if we do that and we hit buttons, it starts appending these buttons on the right. And that all looks fine except for that leading 0. So how do we get rid of the leading 0?
Check if the current string length is equal to 1, and then check if it's a 0.
Okay.
Or you just have a flag over it.
So if the current string is a 0, let's just change it to whatever our new character should be. Otherwise, we'll go ahead and append it. So there's our display. There's a 457. And what happens if we hit a 0? Nothing. Does that look good? Right? It's actually adding that 0. It's replacing the 0 with the 0, but we don't notice. So that all looks good. So we've got input of a single number, right? So let's think larger picture. You're typing in your numbers, 123, and then you hit a plus sign. And what happens when you hit the plus sign? Does anything change on the display?
Depends on the calculator.
Depends on the calculator. We're going to say no. You're going to type in a number and you're going to hit plus and it's going to stay the same. But then when you start typing numbers again, it's going to start displaying that second number. And then when you hit equals, it's going to display the sum. So now hitting the 2 button can do a few different things. If it's the first button you're hitting, it should replace that 0 with a 2. If you've already typed some non-zero numbers, it should shift those over and append a 2 to the beginning. If you've just hit a plus sign, it should clear the display and just display the single character 2. So we've got more states of the system. Okay, so let's start designing a state machine. So state 1, let's use this for the very beginning. Okay, this is waiting to enter the first number. State 2 is entering the first number. State 3, you just hit a plus sign. State 4, entering the second number. And state 5, just hit equals. So we've done state 2 basically. When you hit a plus sign, what do we want to do? Besides change to state 3.
Meaning like keep the number there and
Yeah.
wait for
So we need to record what that first number was. So state 3, you want to save number that's on the display. And if you're in state 3, that's kind of like the initial state. The first time you hit a digit, you want to erase the display and just show that one digit.
unless it's 0.
Unless, well, even it is 0. Depends on the calculator.
Yeah.
But if you say 25 plus and you type a 0, I'd be okay with showing a 0 on the display. But then if you type a 5 after that, you should see just a 5 instead of a 0, 5. And similarly, when you get to the equals sign, you should take number from display plus the saved number. And you should display the sum and go back up to the beginning. So how does this look as a state machine? Here's our state. Waiting for the first number. And if you hit anything, then we say entering first number. And if you have a digit, you stay in this state. If you have a plus sign, you go to this next state, where you just saw a plus. And if you have a digit, then you're entering second number. And digits leave you here, and an equal sign takes you to, just saw an equal sign, and you display that, and that's really your first state. Right, so this can actually take you back to here. And what you do in these states, right, we could specify that, but this is going to be our basic state flow, and actually we're probably not going to come out of that first state unless the person hits a digit. So if you haven't typed anything in and you just hit a plus or an equals, we're just going to ignore it. So your initial state, if you have a digit, then you're entering your first number. When you get a plus, you come down here, record the first number, wait for a digit, enter digits until you get an equals, display the sum, and go back here.
But if you're coming from the equals sign, you have to clear the screen instead of.
So
What are current?
So over here, waiting for first number, I'm going to say once you enter something that's not 0, we're going to clear the display and display that first digit. So we could put some outputs on here if we want. So here we're going to show just the digit. Here we're going to append the digit. You hit a plus sign, nothing changes on the display. You hit one digit, we say show just the digit. And when we're in this state, you keep typing digits, so we append the digit. You hit an equal sign, we don't change it. Oh, well, actually, we show the sum. And then we come back here and we wait until you type a digit and we display that and we start all over again. So that's our basic flow. So can we make this work in code?
Someone else has already done it.
Someone else has done it, we can definitely do it. Appending the digit is this right here. Right, we just take the current text and we add a T, and we can always do this as well. Right, so if the current display is a 0, we won't append, we'll just replace. Well, we need some more buttons. So let's make this an equal sign. Let's make this a plus sign. My buttons aren't big enough. All right, so that's kind of a discount dollar store model calculator now, but that's okay. We could have made the font smaller too. All right, so what happens when we hit a plus button? Let's do the same thing. Let's just call our click routine. And the same thing with the equals. Oh, that's weird, it called them E though. All right, well, we need to know whether or not we got a digit or a plus sign or an equal sign, right? So let's figure that out. So I want to set a flag here to tell me whether I type the number 0 through 9 or something else. And I could take the character and I could use isDigit, but I want to do this myself. So I can make a big long if statement, if t equals 0 or t equals 1 or t equals 2 and so on. But let me offer a different way. Well, Chrome is coming up. That's a string. That's a string. There is a method in the string class called substring. Sorry, index of. So index of will take another string and it will tell you if that string is contained in the first string. And if it is, it'll return the starting position of it, and if it's not, it'll return a -1. So here's something we can do. What does that do?
Wouldn't it return 0 if you typed in a 0? Oh no, yeah, wouldn't you have to be strictly less than?
So if t is a 0, then the index of t in this string will be 0, which is bigger than or equal to 0, so it'll set digit to true,
Oh, it's region, okay.
right? And if t is an equal sign, then the index of equal sign in that string will return -1, which is not bigger than or equal to 0, so it'll set digit to false. So this is a one-liner to basically see if t belongs to that string on the left, which is a string of legal digits. And it's easier than writing a big, long 9-piece, 10-piece if statement, and so on. All right, so there's my first comment. So that tells me whether or not I've got a digit. And we need a notion of state. And I don't want to declare a state variable inside here, because if I do that, it's local to click. And once we get down to the end of click and we exit, all those local variables go away. So I really want this to be declared up in the top of my class. So we'll make a variable called state. And let's document what our states are. So state 1, waiting for first digit. 2, entering the first number. 3, just saw a plus sign. 4, we're entering the second number. And when we hit an equal sign, we'll go back to state 1. So our state variable is going to be 1, 2, 3, 4. And we'll start off in state 1, which is we're waiting for the first digit to be entered. All right, so here we could do switches, but I'm just going to do a bunch of if statements. So if our state is 1, we're waiting for the person to enter a first number. And so what we can do is simply change the entire display to match whatever character was just hit. But let's do that only if it's a digit. And then set our state to 2 and return. So there's state 1. state 2, entering first number, and we're really waiting for a plus sign. So let's do this. So if our plus sign got hit, we're going to switch to state 3. But we also need to remember what that first number was that was entered, because eventually we're going to add it, and we're going to lose the display the next character the person hits. So let's save that first number. So how do we do this? Num1 equals, well, we want to take the thing that's on the display, that's display.getText, and that's a string. We want to convert it to a number, an integer.
So cast the string as an integer?
It won't let you cast it. We have to actually, say again?
Is it like a next int or something?
So there's a method in the integer class called parseInt. And we can feed it a string,
And declare num.
and that'll save it in num1. And num1 has to be a variable.
Or you don't say,
Bless you.
you don't just say, no, I lost my train of thought. It would be like t dot, parseInt. Because I noticed you're saying integer dot parseInt.
Because t is a string, and
Oh.
strings don't come with a parse method.
But the
Okay,
integer
the parse
does.
method is in the integer class.
Okay.
And the reason we're using an uppercase I on integer has to do with statics,
Yeah.
which we're still not talking about, but we'll probably talk about them this week. Okay, well, we're running this method parseInt from the integer class, and we're saving that in num1, which I apparently misspelled or mistyped. Okay, so there's integer num1. So if we get a plus sign, we save it in num1, we set the state to 3, and we return. Otherwise, if you didn't hit a digit, let's just return. Otherwise, you must have hit a digit. So if your display has a 0, we'll just display your digit, else we'll append it. And we will return. And that's the end of state 2. And we don't have time right now for state 3, but state 3 is going to look exactly like state 1. The first digit that you hit is going to replace the display, and we're going to change to state 4, and state 4 is going to look like state 2, except we're going to wait for an equal sign. And when you get an equal sign, we'll parse the display, add it to num1, set the display to that, change our state to 1, and that'll be our whole machine. So we'll pin that code on tomorrow, and that will give us a mostly functioning calculator. All right, so we'll start with that tomorrow.